Hello again. Thanks for joining us on Space Nuts. My name is Andrew Dunkley, your host, and it's good to be with you. This is where we talk about astronomy and space science every week, twice a week, in fact. And on today's program, more news coming from the exo-comet 3I Atlas. Apparently, it is erupting. How so? What can we learn from that? We're also going to look at the boiling oceans of ice moons. That sounds like a contradiction in terms, doesn't it? Boiling ice. But apparently it's happening. More revelations about the former climate of Mars. And this is really interesting. And a whoops-a-daisy with the Soyuz launch pad. That's all coming up in this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And looking better than this morning's golf round at my golf club is Professor Fred Watson, astronomer at large. Hello, Fred.
How are you doing, Andrew?
I'm not sure. If you looked like my golf round, you would be in a very bad way. But you know that's golf. You had some shockers occasionally, and I had one today. So,
well, but last week you were championship winning. So
yes, and we have an old saying in golf: from rooster to feather duster. That's what's happened there.
Oh, I see. Okay. Yeah. Well, feather dusters have their place.
Yeah, not on a golf course.
No,
you can't hit a ball very far with a feather duster. I can tell you that. Yes. What's been happening in your world, Fred? Are you all right?
Yep, all right. I've been having the 30,000 kilometre oil and water tyres check with, I was just saying, my 8th medical appointment this morning since we got back 2 weeks ago. So, yeah. But it's so far so good.
Yeah. Yeah. Well, after we did our 3 months overseas, that was our life for a couple of weeks too, catching up on all those things.
Catching up on the medical stuff.
Yeah. Because if you get a medical checkup on a cruise ship, it costs you a fortune. You just don't get sick on a cruise ship.
No, I wouldn't actually do that. No,
not a good idea. Let's get into it, Fred. And our first story takes us once again to 3I Atlas, the exocomet that has been in our skies since, I think it was discovered in July.
Yes.
And we've been talking about it ever since. And it's been quite an exciting find. And now they've discovered volcanic eruptions. Is that just, a creative license, or is that sort of what's happening?
It's a bit of both, actually. I think so. The idea of what we call cryovolcanoes, volcanic eruptions on cold, icy worlds, is a phenomenon that we've seen before on a number of bodies. We think that Ceres, the biggest object in the asteroid belt and a dwarf planet, as according to our current classification, Titan, Saturn's giant moon Titan, and probably Pluto as well, the dwarf planet Pluto. We think they have all had ice volcanoes, cryovolcanoes on their surface, because their surface temperatures, well, in the case of Pluto, it's way below, it's about minus 230, I think. It's a little bit warmer on Titan and a little bit warmer still on Ceres, but still way below zero. And so the structure of these worlds is, as you know, it's a rocky core with an ocean of maybe liquid water, maybe something slushy, maybe, as in the case of Ceres, a mix with ammonia in it. Because over the top of that, you've got a crust of water ice, which is as hard as rock, and that's what it behaves like. Yeah. But the liquid below, just like magma on the Earth's crust, only that's a lot hotter, but the liquid below is under pressure and sometimes punctures the crusty surface, the icy crust, and you get a cryovolcano, which are a little bit funny looking. They're not, what we think of as a classic stratovolcano, and you and I have both seen Mount Fuji, and we know that's the absolute archetypal stratovolcano.
I've seen them in Guatemala.
Yes, that's right.
They are monsters of things. Those.
Yes, I remember you telling me about.
Yeah, it's right. Quite extraordinary.
But ice volcanoes tend to be more rounded in their in their in their structure. Certainly around the caldera, they've got a rounded top, and I think that's just because of the properties of the liquid that's being gushed out. It's not molten lava; it's molten slush that's, as I said, probably ammonia and water in the case of Ceres. Anyway, the bottom line with all this is that we believe that cryovolcanoes are common on trans-Neptunian objects, and certainly Pluto is a trans-Neptunian object. We think there is evidence that other trans-Neptunian objects out there, things beyond the orbit of Neptune, have got cryovolcanoes on their surface as well. And what's happened is that if you imagine that Comet 3I Atlas, the interstellar comet or exo-comet, as you said, I like that term. It's if you imagine that being from the trans-Neptunian zone of its original solar system, which it probably is, then it may well have cryovolcanoes on its surface. And so that's the sort of premise, I think, from which this work has started. But there is a group of, I think they're Spanish scientists who've used a telescope in Spain, and they've basically looked at the comet when it was close to its closest approach to the sun. In other words, when it was close to perihelion. Now, when it went through perihelion, it was invisible to us. That was on October the 29th.
Yeah.
And because the sun was in the way, and that kind of spoils the view a bit. But what they're doing is taking observations before that and after that as close as they can, and it's all to see what happens to the icy surface of the comet as it gets heated up by the sun's radiation. The brightness of the comet got much higher when it passed the sun. And that's typical because as the nearest point to the sun, the comet's feeling the most extreme solar radiation, both in terms of ultraviolet light and solar wind. And that's when they tend to get most active. So what they're suggesting is that there is basically something that's happened that means that the solid carbon dioxide, which is turning into gaseous carbon dioxide under the sun's radiation, they think that there's been a reaction because the crust. So it looks as though they believe the comet has a crust, and a reaction within the comet has essentially, and it involves the molecules that they mention are reactive metallic grains like nickel and iron sulfides. I'm not a chemist, so I can't comment on that, but I can believe that. And what they're saying is that there's been stuff happening underneath the surface of the comet that has basically allowed gas to erupt from the comet itself. And that's the gas that has caused the increase in brightening, because you've suddenly got a lot more gas around the comet, which is basically glowing because of the effect of the solar radiation. I think that's the gist of the story, Andrew. It's
I'm a bit surprised given how big 3I Atlas is. It's not a huge object in this. Well, if it hit us, it wouldn't be nice, but I would have thought something that small wouldn't be able to kind of erupt, but I suppose it's more of a reaction to its environment.
That's correct, yes. And I suppose what needs an eruption, or what would drive an eruption, is if you've got a harder crust above something beneath it that is more volatile. Less viscous that way. Something that's sloshing around, and I think that's what these scientists are suggesting. And it's their observations of the coma of the comet. The coma is the brightness around the nucleus. The nucleus is the icy body itself. The coma that has brightened up. I think the tail has brightened up as well. And basically they're suggesting that that's due to this phenomenon of a less viscous mantle, if you want to put it that way, because that's what it is in the case of the Earth, that allows an eruption to take place. You're right about the size, though, because at first estimates of 3I Atlas's size, and this is the nucleus that we're talking about, the actual icy object itself, was in the region of 20 kilometers, which would be very, very large for a comet. But I think the latest observations from the Hubble Space Telescope suggest it's much less than that, between about 500 meters and a kilometer or so, something of that sort. Actually, it might be more than that, sort of 500 meters, maybe to 5 kilometers. Something in that range is what they're suggesting.
Okay. And so there's much to learn from this behavior, because we might be able to see what's going on inside.
Yes, that's right. That's the thing about cryovolcanoes. What they spew out is what's inside the object, and so it's worth studying. All the ones that we've seen so far, like on Pluto, Titan, and Ceres, they're all extinct. They're not doing anything. But there's evidence around them. Certainly in Ceres, there's all these chemicals that have been, and you might remember that Ceres has got bright spots on it, which we think are salts left behind by liquid that's oozed up in these, either in fractures or the cryovolcanoes themselves, and left, and as the solar radiation has sort of boiled away the liquid, you've got these salts left, which are really quite white in color. That's why Ceres was such an interesting world when the Dawn spacecraft was approaching it, and we could see all these spots on it. Were they markers put there by extraterrestrial intelligence? No, there were fields of salt.
Oh, someone would claim it. Someone would claim that. No, we continue to be mesmerised by 3I Atlas. It just keeps, for, no pun intended, throwing up new information and interesting things. So I'm sure there'll be more to learn as it keeps skimming our sun, and it'll disappear later next year sometime, won't it? It'll be.
I think that's right. Yeah, it gets below the level that we can detect it, especially if it's only 5 kilometers or less in size. That's not much to reflect the sun's light once you've got all the activity stopping because the sun's radiation's going.
Yes, indeed. All right. I think you can read up on that story at the Live Science website, but I think they've also published their findings in the archive server. Yes, they have. So you might want to check that out there. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a little break from the show to tell you about our sponsor, NordVPN. Now, I've told you about virtual private networks many, many times. I use them myself. In fact, I use NordVPN, and I did pay for it. So I feel even more qualified to tell you what I think. And I've used it overseas recently, and it works. It's one of the most trusted and widely used VPN services in the world, and for a very good reason. It encrypts your data, it hides your IP address, it makes you much harder to find online from anybody trying to steal your passwords, steal your usernames, sell them on the dark web, or just get into your bank accounts and clean you out. Whatever their motivation, it's not usually very good for you if they succeed. But the way to protect yourself is with NordVPN, top-tier security. And we're talking about the same standard of security trusted by governments and cybersecurity experts. They have a global network. They've got thousands of servers in over 60 countries around the planet, and no geo restrictions as a consequence of that, and very fast speeds. In fact, I have actually experienced higher speeds connected to my VPN at home compared to what I'd normally get from my internet service provider. I don't know how that happens, but it certainly has happened a few times. They have a strict no-logs policy, which means they don't track or store your browsing history. And they offer all sorts of other tools like threat protection, dark web monitoring, and a kill switch for added safety. Now, if you'd like to find out more, there are discounts at the moment for Space Nuts listeners, and it's really quite simple. Just go to nordvpn.com/spacenuts. That's nordvpn.com/spacenuts. And then you click get the deal. Don't forget they've got a 30-day money-back guarantee. And you can get an extra 4 months free by signing up as a Space Nuts listener. So click on Get the Deal. They have plans that you can pay monthly, or you can go a year in advance or 2 years in advance. And the longer you sign up with them, the better the discounts. So go to nordvpn.com/spacenuts for your online security today. And don't forget the code word Space Nuts at the checkout. nordvpn.com/spacenuts. Click Get the Deal, and then have a look and see what suits you best.
0G, and I feel fine.
Space Nuts.
Now, you might think it's weird that an object as small as a comet could, have a cryovolcano, but what's even weirder is this story about ice moons having boiling oceans. Do tell.
This is work from, I think, a number of authors, some at least of whom are from the University of California, Davis. The lead author, Max Rudolph, is from that institution. And they've been thinking about the exact details of the structure of the ice moons that we so often talk about on space shows. Once again, that structure, a rocky core, a liquid ocean over the top of it, and an icy crust on top of that. So they've looked in some detail at the physics of this, and what's driven that are things that we see on these ice moons and some of the contrasts. For example, you've only to think about Enceladus, perhaps the poster child of the ice moons because of the geysers of ice crystals that erupt from its southern pole. And the region where those geysers erupt is very fractured. In fact, the fractures were discovered first before Cassini spotted the ice geysers, and they were called tiger stripes because they're sort of blue in color. I'm not quite sure why a blue tiger would have those stripes, but anyway, that's what they look like. They look like stripes on a tiger, but they're blue.
It is
on a white.
A stunningly beautiful world.
Yes, it is. Absolutely, I agree with that. But contrast that with Mimas, which is one of Saturn's moons that is, it's in the same region of the solar system, but it is totally, totally different. It's got an ancient surface, peppered with craters, one of which is huge and makes it look like the Death Star. That's why Mimas, I think, is the poster child of science fiction readers rather than physicists. But they've all got the same structure. So why are they so different? And so these scientists at University of California, Davis, and elsewhere have looked in detail at that, the physics of what happens. And so it a lot depends on how they manage to maintain their internal heat. And certainly in the case of Enceladus, and I think this is probably true with Mimas as well, but to a lesser extent, you've got tidal forces. You've got a giant planet, in this case we're talking about Saturn, which is your next door neighbor, and having something that big, that near, is going to exert really strong tidal forces. And tidal forces are ones that tend to stretch and squeeze a body like a moon. And so that's where we think most of the internal heat comes from. Certainly in Enceladus, that you've got Enceladus in an orbit that is not circular, and so as it's nearer and further away from Saturn in its orbit, it will be stretched and squeezed. That causes frictional heating, and that in turn keeps that liquid water ocean liquid rather than letting it freeze. So, but what they have suggested, these authors, is if you think about what's happening here, the ice above the ocean, when you've got stronger tidal heating, that shell of ice can melt on its underside. And we know that ice is odd in that it gets bigger as it freezes.
Yeah.
That's why you get burst pipes, because when the ice freezes, it gets bigger.
That's right.
And so if the ice melts, then you've got basically a smaller volume of ice. And what they're suggesting is that when that happens, when the ice shell melts from the bottom, you get effectively a vacuum above the liquid. Or it wants to form a vacuum because the pressure's suddenly low. And what that can do is cause the liquid to boil. I don't know whether you've ever seen liquid boiling under low pressure, Andrew.
No.
It's pretty easy to demonstrate. If you've got a hypodermic syringe or something like that, a transparent one, I used to use them for dropping bits of liquid onto things when I was building fiber optic systems at the observatory. But if you've got a hypodermic syringe and you fill it with water and you put your finger over the end of it and then pull back the syringe piston, the water will boil because you create a vacuum above it and it basically just boils. It's quite dramatic to watch.
Does it boil hot, or is it just...
No, it's boiling at room temperature.
Wow.
So what we're talking about here is something that's boiling at much lower than room temperature, because you've got ice above it. But if the pressure's low enough, the water will boil, and that's why you can't have liquid water for very long anyway on Mars, because the air pressure above it's too low. So yes, the suggestion is that we might get this boiling, and what they're saying is that could give you some of the strange or the differences in terrain that we see between the moons. If I can, let's see, this is from SciTech Daily. This is, it might be a press release actually by University of California, Davis. I was going to read from it. I want to credit the origin. Let me say, so Mimas, that's the Death Star ice moon. Oh, as it says, I'll read the whole thing and I won't comment on it. Images. All right. There's another world that they're talking about, which is Miranda, which is one of Uranus's moons. We'll forget that for a minute, but we'll just talk about Mimas. Less than 250 miles across and pitted with craters, including a very large crater earning it the nickname Death Star. It appears to be geologically dead, Rudolph said, lead author, but a wobble in its movement suggests an ocean is present. Because Mimas's ice shell is not expected to break as a result of ice shell thinning, the presence of an ocean can be reconciled with a geologically dead surface. But what they're then saying is that if you've got a thinner ice shell, then you'll end up with a surface like the one on Enceladus with stuff actually bursting through it. Okay. Really interesting piece of work. It's in Nature Astronomy, so it's a top-level journal that this is published in. And the paper in Nature Astronomy is called Boiling Oceans and Compressional Tectonics on Emerging Ocean Worlds. There you go.
Yeah, I mean, when I was a kid, we didn't even know that ice moons existed. I'm sure that
when you were an adult, you didn't know that they existed.
No, but now we're finding more and more of them. We're starting to go, well, hang on a minute. Pluto could be one of these too. And the list just gets longer and longer.
Yeah, it probably is.
Yeah. And so much to learn. And of course, as we've mentioned many times before, there's a lot of excitement in regard to having worlds in our solar system with liquid oceans because, water means life on Earth. So could it be the same elsewhere? It's it's a mystery that's going to be resolved in the not too distant future, I imagine.
We can but hope so. I mean, our friend Linda Spilker, former Cassini mission scientist, she's working on a flyby mission to sample the geysers of Enceladus again, with a view to looking for exactly that, evidence of living organisms in the sub-ice ocean of Enceladus. I hope we are space nutting long enough to get the results of that.
And of course, Europa Clipper's on its way too.
Yeah, that's right. Yeah, and so Europa is another ice moon, similar, similar story. Yep.
Yeah. we watch with interest. As Fred said, you can read all about it on the website SciTech Daily, or you could go to the paper itself, which is down the bottom of this particular article somewhere, and I've lost it. But yes, it is a published document. Nature Astronomy. There it is, right in front of me. This is Space Nuts with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
The more we look at Mars, the more we study Mars, the more we start to learn about it. And there's a new piece of evidence that's been discovered, and I believe there's another paper been published saying we think that not only did Mars have an atmosphere, it had and oceans, we already know that, but it looks like for billions of years it had a near tropical environment with pouring rain and all the things that we take for granted on Earth. This is quite an amazing claim, I suppose you'd call it.
It is, yes. So lots of I guess comparisons being drawn here, and our old friend phys.org has got a very nice article entitled "Evidence of Rain-Driven Climate on Mars Found in Bleach Rocks Scattered in Jezero Crater." And Jezero Crater is where Perseverance is, and that is something that is kind of expected because Jezero Crater was once a river delta from water that flowed from a river into the crater itself. And we have plenty of evidence that happened maybe 3 to 4 billion years ago. But what is now happening is that Perseverance is actually having a closer look at some of the rocks around and has discovered some... would you excuse me just a moment? No, that's not going to work. I'm just going to ignore that as a phone call. I'll have to ignore it. There's no point in sending a message because it's not coming from a mobile phone.
Oh, right.
Yeah. Sorry. Keep going. You can edit that bit out, Hugh. What has been discovered by Perseverance are aluminium-rich clay rocks, and well, I'll read the sentence. It's a lovely summary of what the story is. As I said, it's on the phys.org website. The rocks discovered by NASA's Perseverance Mars rover are white, aluminum-rich. I should read it properly and pronounce it properly. We call it aluminium. Other side of the Pacific calls it aluminum. So that's where this came from. So let's call it that. They are white, aluminum-rich kaolinite clay. So kaolinite is a clayish mineral, which forms on Earth after rocks and sediment are leached of all other minerals by millions of years of a wet, rainy climate. That's the bottom line. And it's exactly as you've said, evidence for rain, long periods of rain. And, you know, what this speaks of is, and this is, I guess, the big question about water on Mars. Were these lakes and seas that we know were they there just, you know, sporadically, just once in a while for a few million years, but not there permanently? Or were we talking about oceans that themselves lasted for millions of years? And some of the recent work, as well as this particular piece of work, definitely support the latter. That there was rain falling for millions of years, and it was probably a tropical climate, exactly as you said in the intro, Andrew. So one of the authors has commented, so when you see kaolinite on a place like Mars, where it's barren, cold, and with certainly no liquid water at the surface, it tells us that there was once a lot more water than there is today. And it's somebody who's actually a collaborator on the Perseverance rover. So, yes, more evidence still that we had a wet, warm past on the planet Mars, and just maybe we had life there, because the sort of rocks that we're talking about, the kaolinite, are thought to be a little bit like a time capsule, that there might be information in those rocks from billions of years ago that tell you about whether there were living organisms on Mars. And that is the sort of holy grail of all this work. Whether a chunk of kaolinite would be something that the hoped for Mars return mission would be able to bring back is another question. But maybe Perseverance will drill samples from it so that we might find out, because those caches of drilled samples are what we're expecting to come back to Earth at some point. At the moment, there isn't actually a mission on the cards that will do that.
Yeah, I know, and that's frustrating.
Very.
But that's just the way it is at the moment. But I was just reading that the ocean or the lake that existed in Jezero Crater, they say is about twice the size of Lake Tahoe. That would probably mean something to someone. I had to look up how big Lake Tahoe is, and they're talking 496 square kilometres. So the lake that they're investigating, or the remnants of it on Mars, is twice that size, 1,000 square kilometres. So, it's pretty amazing stuff. And, getting up close to some of this evidence is really starting to provide people with the fuel they need to come up with pretty solid theories, I would suggest.
Yep. Or even liquid theories.
Yes, maybe. Maybe. Because they keep saying, where did all the water go? They must have, and makes you wonder now, if it had billions of years of saturating rain, I'm guessing it wasn't continuous. It was, like it is on Earth, comes and goes. But there must have been a heck of a lot of water around at some stage.
Yeah, and we know that a lot of it's still there, locked up in the permafrost underneath the surface, and in the Arctic and Antarctic regions of Mars, there's the ice caps themselves have got huge amounts of water locked up in them. But a lot of it also leached off into space. We know that Mars has lost a lot of its water by the hydrogen and oxygen atoms being dissociated, and off goes the hydrogen because it's very light.
Indeed. All right. If you'd like to read up on that, as Fred said, it's at phys.org, or you can read the paper. The findings were published in the journal Communications, Earth and Environment. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Space Nuts.
Finally, Fred, a bit of a bummer, really. A whoops-a-daisy with the Soyuz launch pad after a launch the other day.
Yes, that's correct. So the launch itself was successful, and it's an important one. It was, I think, Soyuz Mission 28, if I remember rightly. I haven't got the details in front of me. And took 3 astronauts, or 3 space people, up to the International Space Station, 1 NASA astronaut and 2 Russian cosmonauts. So they were ferried up very successfully to the International Space Station. They docked about 3 hours after launch, I think, and are now happily in the space station and doing what you do in the space station, which is
play chess with magnetic chess pieces. That's what you do,
among other things. Yeah, but
I wouldn't like to play a Russian in a game of chess. That absolutely cream me. They're pretty good at that, aren't they?
I think they are, yes. That's where a lot of the world chess champions have come from, indeed, yes. So the other side of the coin, though, is that something went wrong with the Soyuz launch platform. And apparently a service platform, which is needed when you're preparing the spacecraft for launch, was not properly stowed. This was about 20 tons worth, I think. And that basically was blown down into the flame trench, which is underneath where the launch takes place, and did a lot of damage. So I think Roscosmos, the Russian space agency, is playing it down a bit and saying, oh, no, we've got all the bits we need to mend it.
There's nothing to see here. Well, they've got all the bits. They're just absolutely shattered and burnt and stuck in a big pit.
In a pit, yeah.
Yeah, I mean, but this is journalism one-on-one, Fred. We've got everything. It's all there.
Yes. It's just in pieces, that's all. And some observers, some probably Russian journalists have said, yeah, in your dreams, this is going to take 2 years to fix.
Yeah.
So we don't know the answer. It's important because that is the only this is at Baikonur, where the main launch site is in Kazakhstan. That is the only launch pad certified for crew carrying Soyuz flights. And I think the next crew carrying flight is scheduled for the middle of next year. So there will be a rush on to get that organized. I think the Progress cargo modules have to be launched from there as well. And I think there's one of those supposed to go up in a couple of months' time. So there might be, we might see some delays in the program. We'll have to watch how that goes. And it may even be that SpaceX could come to the rescue with a Crew Dragon up there or one of their Dragon cargo modules. Let's see what happens.
Wouldn't that be interesting? Yeah. I think they did have an issue recently with some stranded Chinese.
That's right.
Astronauts. And
they're still up there, yes.
Yeah. And now we've had this issue. And of course, we've had issues in the past with stranded American astronauts and the Boeing Starliner problem. And look, these things are going to happen. That's the nature of space. It's a high risk environment. You're playing against the odds a lot of the time, and losing a chunk of space pad's probably a small price to pay.
Yeah,
as you say, it's a critical launch pad, and that is the problem they now face, getting it back to operational status, because it's the only one they can use for human launches. But it's an unfortunate. The other interesting part of this story, which is not really about the story itself, is that you've got this cooperative approach between NASA and Roscosmos, while the political arms of each country are at each other's heads over the war in Ukraine. So, I mean, this is just nuts, isn't that the weirdest thing about humanity?
It is. To me, it speaks of what can be achieved, though.
Yeah.
Why aren't we doing this throughout the whole of humanity, rather than space in a way has focused people on the absolute need to react as though we were one species and one community, because in space, that's what it is. Space is hard, exactly as you've just said.
I've just written 13 chapters of my new science fiction novel, and I go exactly with that point, that humanity's had to put all of its differences aside because we've got a bigger problem to deal with, and they're not here.
Yeah, that's right. Well, I'm glad to hear that. It sounds like an interesting book.
I'm having a lot of fun with it. I'm just letting my imagination run wild, and I write on the fly. I don't actually sit down with a plan or a novel, board with all the scenarios. I just let my brain go, okay, where's this going to go next? And sometimes it takes me to some weird places, but I've developed this character. He's a bit of he's from Earth, but I'm having a lot of fun with him.
He doesn't play golf, does he?
No, but he's playing silly buggers. I think this guy, all right to describe it. He's going. I don't know where I'm going to take him, but so far so good. It's been fun to write about, but I think the novel will be called The Orb. But I don't. That's the working title. I might stick with that, but we'll see how it goes. But I don't know when that'll be finished. I'm hoping to make it an epic, so it might be or maybe even 20 or 30 pages by the time it's.
Okay,
see how it goes.
What if your longer novels?
Yes, indeed. But yes, interesting times with cooperation in space and a certain lack of cooperation on the surface of the planet. So hopefully they can get that Soyuz space or launch pad all fixed up. You can read about that. It's all over the news, but spacenews.com has a good story about it. Fred, I think we're done.
Well, that went quickly.
Did right.
Just like one of your novels.
Yeah, well, yeah, that's right. We'll see. But yes, thank you, Fred. It's a pleasure as always.
We'll speak again soon, I hope.
We will. Professor Fred Watson, astronomer at large. Don't forget to visit us online. You can do that at various social media spots, Facebook, where we have an official page, and we have a user-generated page, the Space Nuts podcast group. always a lot of fun. You can find us on Instagram as well. And if you go to our website, maybe consider becoming a patron. We would never make it mandatory, but it's a way of giving us a little bit of an injection. If you would like to help, you can do that at Patreon, Supercast, PayPal, or there's a button that says Buy Me a Coffee. I love coffee, so you might want to look at that at spacenutspodcast.com. Unfortunately, Hugh couldn't be with us today because he ate something that didn't agree with him, and he's sort of acting like a cryovolcano. He's lots of crying and lots of volcano. Let's just leave it at that. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.